Greetings everybody, and welcome to Euclid's proposition number 12. In this proposition we are given a straight line and we are given a point which is not on the line. And we want to show that we can construct a line perpendicular to the line we were given, which also passes through the point that we were given. So let's take a look and see how the proof of this one might go. We begin by choosing a point D, which is on the opposite side of the line from the point C that we were given. So we just choose any point on that side. Now, from one of our postulates, we know that we can draw a circle C that's centered at the point big C and which passes through D. If we do so, then that actually gives us two other points of intersection, say E and F. Now for this particular proof, we don't really need points A and B anymore, so let's take those out so that they're not cluttering things up. But from our circle C, we can see that we've got two line segments from C to E and our line segment from C to F. And because E and F are on the circle centered at C, then it means that our line segments EC is congruent to our line segment CF. At this point, we're done with our circle, so let's take that out of the situation and let's remove point D from our figure as well. Now from proposition 10, we know that we are able to bisect a line segment. And so we want to bisect our line segment between E and F. And remember, to do that, what we had to do was draw a circle centered at E passing through F. And then we drew a circle at F passing through E. And that gave us two intersection points, one on either side of the line. So that would give us point G, and it would give us point H. Now drawing that line segment between G and H gives us a point of intersection with our line segment EF that happens at point I. And that point I was our point which bisected our line segment E and F. And so once we have our point I, now we don't need our circle, and we don't need our circles, we don't need G anymore, we don't need H anymore, and we don't need our line segment between G and H anymore. And so that gives us our bisector of EF at our point I. Now because I bisects our line segment EF, it means that we've got congruent line segments EI and IF. Now if we put in our line segment between C and I, that gives us a familiar setup once again where we have two triangles, CEI and CIF, which are going to be congruent by our side-side-side congruence property, which was proposition number 8. So from this congruence of our triangles CEI and CIF, we have that our angles between sides 2 and 3 will also be congruent. And in addition to the fact that those two angles put together form a straight angle, EIF, it means that our two angles, EIC and FIC, are both right angles. And hence what we have is that our line CI then is perpendicular to our given line AB, as was to be demonstrated. I hope you guys have enjoyed this, and I will see you in the next video. Take care.